Hi, this is Chong Kim, and today I'm going to do Tic Tac Toe in C. I'm using Visual Studio Code. I think usually I use Vim, but I've been liking VS Code, so I'm going to try using that. So I'm starting from a blank directory. There's no files, and I'm going to create a file, and I'm going to use TDD. So first thing I'm going to do is I'm going to write a C code to set up my testing environment. I haven't found any testing framework, so I decided that I was just going to use straight C. So let's start. Okay, so the first thing I want to do is I want to set up the testing framework. So I'm going to have a suite of tests. So I'm going to say struct. Well, I'll type this. So struct. So basically, when you say type def, the difference is that when you say struct like this, and you give it a name, like let's see. So if I say struct test suite like this, then I'll need to say struct test suite, like to define my my suite. And this I don't like this, so it's good to like type def it. So you would basically say type def, and you give it the type here. I would say test suite like this, and then now instead of saying struct, I can just say test suite like that. So it just makes it a little bit nicer. And because I'm not using this internal struct anymore, I don't have to give it a name. So I could just say type def struct and then give the parts of it. So the test suite, it'll have a function. So some function here, I haven't specified the type yet, and I want to, and I think that's all I want to do for now. So the function is going to be, oh, actually I want to have the name of the function. So I would say something like card name, like that, for example. And for this, it's going to be some integer. It's a function. Okay, so the way to write a function declaration is say it's a pointer, because it's a pointer to a function. It's a pointer to a function, like that returns an int. So the int will be the return value. So then I could specify int test in it. So test create, actually. Let's call it create. Oops, I'm so used to Python. All right, so test create. And let's see, what do I need to do here? Okay, so when I'm creating a test, well, okay, I'm just going to return 0, like it failed, just so that I can have, since I'm setting this up, I'm not going to concentrate on writing the actual test. So to set this up, I can, and I need to specify two parts. The first part, oh, actually, this is just to specify a type def, and then now I can just say test suite suite. Actually, I have the bottom part right there. So this is the suite, and the first part it expects is the function, so it would be test create, and the second part is the name, and that would be test create. So, and the function is going to be, I'll just call it main, so int main. And I'm going to go loop through, oh, actually this test suite, I wanted it to be an array of test suites. So test suite is, okay, so actually I should have just called it test function. That'd be good. So the test is an array, so a suite is an array of tests. So the test is here, okay. So now I'm just going to iterate through the suite. So question is like, how big is the length of the suite. Normally you would say length of the suite if you were doing Python, but in this case, you would say, you would have to get the length of that array, it would be the size of the suite. The size of the suite will say how many bytes this takes up. So this is an array, and I have only one item, and so it'll be the amount of space that is needed to store one of these. So it's going to be an int and a character. But usually it's rounded off to like the nearest 4 or 8 bytes or something like that. So that's the size of the suite, that's the number of bytes, but then to get how many of them, I have to divide by the size of the type. So the size of the test, right? So that's the length. Now I can iterate through it for int I equals 0, I less than len, and I plus plus. All right. And I'm going to get the test, actually, we have the suite I, right? Actually, we can just say test is equal to suite I. So now we have the test, and we want to call the function. So it's test.function, and so we dereference it to get it to be the function, and we're going to pass it. It doesn't take any arguments, so we just call parens on it. And I think that's it. And we need to store the return value, so the result. And if the result happens to be, let's see, success, we're going to say success is 1 and 0 means failure. So if the result is a failure, so that means if it's 0, actually we can treat it as a Boolean. So it's like, we can just say passed. So if passed, this makes it a little bit more readable. So in a Boolean, it's any non-zero value. So if it's passed, then we're going to, if it didn't pass, put a not there. If it didn't pass, then we're going to print it out, the name, and actually we can say if it passed, then we could say passed, and we'll give it the function name. So %s, we're going to specify that in the arguments. So that the name happens to be test.name. So that's the name. Okay. All right. So, all right. And then if it failed, else, printf, and then we just say it's failed, and give it the test.name. All right. So we're going to test this out. So far, there's looking at the bottom over here, we see that there's no errors or warnings. So we should be good. We can, well, actually, I can probably just stay within here and just run it from here. So I could just cc, let's see, test.c, and if that passes, then we're going to run it. Okay, so printf is, it says implicitly declaring library function. So basically it's saying that it hasn't been declared. So we need to import hash include standard.io, standard.io.h, and that should take care of that. And let's see, I wonder if there's an easier way to get there. Actually, I think I might as well just use this, because I could just command tab it, just much easier. So then I could cc the test, and if it's successful, we're going to run it. Okay, and it failed, which is what we expected because we returned a 0, it failed. And one thing that I didn't do here is put a character turn at the end. So This way it looks a little bit nicer. So now if I run it, it says test create failed. So one improvement I want to make is, yeah, one improvement I want to make is I want to define test in caps and give it the whatever the function happens to be. And so when you have it defined like this, this is a macro, so it'll replace so the way I'm going to use this is I'm going to say test create, like that, just like that. So I don't have to repeat myself when I say test create, because errors can happen because if you specify a name and it doesn't match with the function, then you're going to be looking in the wrong place. So instead, I want to do this to make sure that it's set up correctly, and you only specify it once. So how do I do that? So I would specify the function in here, and for the second argument, I do hash fn. So for this macro, if you put a hash there, then it'll give the string representation of whatever you passed in. So it'll basically turn that into a string. So we can test to see if that still works, and that still works. That's great. All right. So the next thing, so we have basically our testing framework set up. Now we're going to actually make this into a real test. So I'm going to do create, create position. Okay, I haven't created the type yet, but I'm going to create a type called position equals create. I should say create position. All right, and that'll just give me just an empty position. So first I have to include ttt.h, and I'm gonna define that. So I'm going to create a new file, save it as ttt.h, the header file, and just extern create pos that will take a position. Oh, it doesn't take, it returns a position. So it does this, and it returns a position. And we haven't specified what a position is, so then we're going to use that type def again. Type def struct, and we have to say type def of what? So you give it the type def of the type and then the name, so position belongs here. So what does a position consist of? Well, it would be an array of characters for the board. So character, array would be 9 because we only have 9 squares. But we actually want to treat it as a string with a null at the end, so we'll put it at 10 characters. Notice a little bit, I wanted to point out something here which causes a lot of confusion for beginners. Oh, actually I didn't specify the name. So that would be the board. So one interesting thing to note is in the original, in the test, I had character star here, and I'm using character array. Now, in use, it's pretty much the same, but there's a subtle difference here. The difference is that when you have a struct that has a star in it, that means it's a pointer to an array, which means that the array is not part of the struct. It's outside of the struct. So the only amount of space that this takes up is the size of the pointer. And this makes a big difference because when you're passing this around as arguments, for example, or when you assign it, then the pointer is being copied, not the whole array. Now this, when you say character with brackets in here, this is an array that is part of the struct, which means that all those elements are actually part of the struct. So if it's 10, then this will take up 10 characters inside of the struct, not the size of a pointer, which is like about 4 bytes or 8 bytes. So that's a little bit of a difference. So it's actually making a copy of the whole array. the next thing I want to do, I want to specify whose turn it is. So I'm going to say turn like this. And that should be enough for the position. So now we see that the errors have gone away. So going back to this, so far we're back to 0 errors and 0 warnings. So going back to this, we see that we need to actually make a test, right? Because we're just returning 0 as failed. Actually, we might as well put like hash define pass is 1 and hash define fail as 0. So this way we'll just, oops, I pressed E by mistake. Oops, okay. So we might as well, okay, so we had this as failed before. So we should actually make a little comparison. So if we want to make sure that the pauses board, actually we use a string compare, right? String compare the board with, and we want to make sure that it's filled in with empty spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be 9 spaces, right? So if, and this is compared to 0. So that means that if the first string is less than the second string, if you want to test that, then you would say less than. And if you want to see if the first string is greater than, then you would say greater than equal to 0, greater than 0. And if it's equal, then you just say equal to 0. So that's the only thing that you have to remember. So when you're using string comparison, it returns a negative number, a positive number, or 0. So you just compare it to 0, and now you know the relationship between the first and second string. So basically, this is saying if the string is equal, actually I want to say if it's not equal, then we want to fail. So we would say return fail, right? And at the end, if everything succeeds, we say pass. Actually, I wonder if I should say success. Fail and success seems to go together. So that's a little bit better. So I'll just call it success. All right. But as it's failing, I actually want to put some extra information in here. So I'll say something like printf, probably the board. And I might as well put something around it like a bracket, %s, so we know at the beginning and because there's white spaces involved. So is not right. Let's just do that. It's not correct. Okay, and we'll print it out. We'll print it out and use board. This is why I wanted to have a null character at the end of it, because if we treat it as a string instead of just an array of characters, then we can print it out because it has a null character at the end. Okay, so that's assuming that the create pause is set up properly, and it's I don't think, yeah, we haven't written that yet. So now we should run this, and I think it, yes, there will, oh, actually it's complaining because we didn't have string compare defined, and that is defined in string dot h. Okay, so then we run it again and could not find create pause because we didn't write it. So we should now create the ttt.c file. So now we're actually going to write it. So save this under ttt.c, and we might as well hash include the ttt.h. Okay, and we're trying to create create pause, which returns a position. Okay. So one other thing to note is a lot of times you'll see in C that it, when you do creation, it's creating like it'll create something like a pointer to a position instead of just the position. And I wanted to avoid that because I wanted to keep this thing simple and to show you how to write code that doesn't involve pointers using malloc. And but we could we would probably get into that a little bit later or in another episode. So to create a position, we already have a position type, and we can say position, pos, and we can initialize it as we declare it by using the curly brackets, and it'll copy over the bytes. So it's actually kind of convenient to do it this way. That's one of the reasons why I had it as a character array instead of a character pointer. Because if it was a character pointer, then it would only copy over the pointer to the array. And sometimes that's not what you want, because you may want to modify it. And if it's a constant string, you won't be able to do that. Okay, so okay, so we need 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so we have that many bytes, and it'll copy it, and the character, it's x. So basically it's saying it's x's turn. So this should be enough, and put a semicolon at the end, and we can just return the position. So let's see if this works. Oh, and when we are compiling it, we also have to include the ttt.c. Okay, so now it passed. That means that everything looks right. Okay, let's go back. Okay, so what's the next thing we need to do? We need to create a... Oh, actually, I haven't figured out what... Oh yeah, actually, this is a test, so it always returns an int. Okay, we have the test create. Oh, actually, there was one more thing that I needed to test out, is if the board, the turn does not equal to x, because we expect that it's x's turn because x is the first person to go. If it's not x, then return fail. And we should put a little message here saying that turn is that character. Put character turn at the end, and pos dot turn. Okay, so this should give a nice little error message if that's not the case, and we can just test this out, and it should pass. And just to show you that if I put an O here, now I say the turn is O, and the test create failed. Okay. Actually, you know, I think I might as well put some arrows in there, because it's hard to see when something passed or failed just by this. So I think I might as well put some, maybe, actually I'll put an arrow in the error message just to so might as well do something like this so it'll stand out a little bit. Okay, turn is O. All right. One thing that you might have noticed is in my code, you see these special symbols, but really, if I put a space over here, right, I'll just, so I can break it apart. They're really not any special characters. They're just dash dash greater and exclamation point equal. And I have ligatures set up, so it kind of looks nicer when, you know, they're put together like this, because you see this a lot in code, and it's kind of nice to see it this way. And also, let's say less than or equal to, greater than or equal to. So these are ligatures. All right, so okay, so now it works. We just put it back there. Okay, so this will pass. The next thing we need to do is we need to be able to make a move, right? So test move. And for this, I am going to, okay, so I'm just going to make a position. So create position. And I'm going to say pause. Oh, it's not a method. So I say move pause. Oh, I have to give it 1. And that will return you a new position. So I could just say, I could just assign it. So now it's just a new position. And yes, this is throwing an error because I haven't defined move yet. So Okay, just let's assume that I have it, and the assertion is if string compare. Okay, this is my expectation is that the board will equal an x there, 1, 2, 3, 1, 2, 3, and the turn will be O. Oh, actually, that's the next part. Okay, this should be equal. So I'll just say if it doesn't equal 0, then this is an error. So return fail. And I'll just put a little print statement here. So whenever there's like an error, I should really put like arrow so it just sort of stands out a little bit. Okay, so I might as well put the board like this and say, actually, expected is equal to, might as well put it here like this because I don't want to repeat myself. So I'll just say expected and does not equal expected. Okay, I'll just say actual here. The actual is not equal to the expected that, and so actually I haven't declared it, so this is a character star. Okay, and this one, so the actual is the board, I'll print out, and the expected. All right, so see if, and I haven't declared it yet, so I'll just say it returns a position where you have, okay, we have move, taking a position and an integer. So that's what, and we need to position, oops, move, given the position, and oops, I have to specify the type position and the, I'll just say I, the index. And for now, I'll just return the position, just to show you. First, start with a failing test, right? Making sure that everything still works. So if I run it, let me see. Oh, non-void. Okay. Okay, so it's line 30. So line 30 on, is it test.c? Yeah, test.c. So let's go to test.c, line 30. So there's a problem over here. Oh, it's because the return type is int. I have return fail, but I don't have a return over here. So the default should be return success. Okay, so let's see. Oh, and I forgot to add that to the suite. So we have this. So we're going to have test move. And all right. So the first one passed. Second one, the actual is an empty array, but I was expecting x to be put into the first column. So let's make that real. Actually, I want to put a little bit of space there, right? Yeah, just so that like the output looks a little bit cleaner. So let's go back to this and actually make the change. So there are two things that needed to be done. Actually, in the test itself, well, let's do one at a time. So, so I'm going to create a brand new position. The reason why I'm doing it that way is because I wanted the original position to be unmodified. So if I were to say position board I is equal to, and whoever's turn it is, so position dot turn, right? Then the position that is returned will have the modification, but so would be the input. And we don't want that because we want to keep it separate because it'll make sense later on when we want to do evaluation recursively. And if you do it recursively and you change the original structure, then the recursion won't work. So we need to keep the original value. So that's why I'm passing it in, and I'm not doing it this way. So we need to make a copy of it. So we could create a position. So we can call this, we'll just say new position. New position. And we can use the same structure like this with the array. So pos.board. And now for the turn, we want it to be the opposite, right? So we'll use the ternary operator. So it's if the pos.turn happens to be x, then we want it to use an O, otherwise an X, right? So this way, so basically it's the other guy's turn. So the new position is set, except it doesn't have the updated board. So now we update the board using the position's turn, right? Because that hasn't changed. Okay. And there is a problem with this. Oh, I forgot the semicolon right there. All right. And instead of returning pos, we return new position. So this should give us a clean move without having to modify the initial input. So let's see. All right. Actual. Okay, so interesting thing over here is, okay, so I think that the copy didn't, okay, so it looks like the way that I did this didn't work. And okay, so I think the reason why is because this is giving the array, all right, so I'll just say, let's do it a different way, create pos, and just do it manually. So new position dot board, we just do a string copy. Okay, so string copy, see how like string copy works. Like string copy, it doesn't have, okay, so I see, so I have to like hash include string. Okay, so now at least it'll know about it, and actually, there it is. So the first argument to string copy is the destination. Okay, so so that makes sense. So here's the destination, and we want to copy it from the board like there, right? So that will copy the string, okay, and then new position dot turn is equal to this. All right. So I thought I could be tricky and do it, but I guess that didn't work. All right. So and then after we made a copy, okay, now this should work. Okay, so they both passed. There is, I don't think did I make both tests? Let's see. Test move, we tested that, but we also wanted to make sure that now it's the opposite turn, right? So it started off with an X, and then it should have been an O. So if board.turn, I'm expecting it to be an O. Oh, if it's not equal to O, right? Because then I wanted to expected O. Okay, I think that's good enough. Expected turn to be O. And let's see, actual. Might as well put the actual, and then put, it's a character, so it's a C. And here we put position dot turn. And then we just return fail. Okay, so everything is good so far. The next thing we want to to test is test. Okay, we're able to make a move. Now we want to check to see whether or not something is one. Win. Okay, so this is going to be set up a little bit differently because now there's a few different scenarios. So I might as well create a type def over here, and it's a struct because it's going to be like multi-part. The first part of the struct is the board. So I'll just say the board. Actually, the position. Might as well just do a position. And then, oh, then actually it's just an array of positions then, because I don't think I need anything else. All right, that makes sense. So then it would just be, let's see, I'll just say positions, test positions. Okay, and it's an array like that, and use the curly braces to specify the array. Okay, so what kind of positions are we looking for? And you use curly braces for each of the positions. So we want to make sure that, let's see, XXX and 1, 2, 3, 1, 2, 3, and it's O's turn. Okay, that this is considered a win, and also this is considered a win, and this is the opposite of these letters because X just moved. So then once X moved, now it's O's turn, and yeah, we just want to make sure we capture this, and we also wanted to check this version. I'm just going to do a few. Okay, so so 1, 2, 3. Okay, so I think that way, right? So this would be across the first column, right? 1, 2, 3, 1, 2, 3. This is the second row, and then this is the third row. All right, and that should be considered a win. Also O, right? Okay, and then we have the diagonals, right? Diagonals are a little bit tricky. So let's see. The way the diagonals are is if you start with 1, okay, the first one, then the middle one, so the middle one, and then the last one, so 1, 2, X, right? So this would be considered the major diagonal, right? And I'll just, okay, and then you might as well change this as well. Okay, and the last one would be the minor diagonal. So 1, 2, 3, not 1, 2, 3, 1, 2, and then 3, X. And then the middle one would be here. And then the first one, okay, right there. So that would be the minor diagonal. Okay, and might as well just change this for the O's. Okay, and all right, so that's the array, and now we can write the rest of it. This time we put into a for loop to go through each one. So the length, how many there are, in case we wanted to, I don't want to put a hard-coded number on here because if we want to add more, delete some, then I don't want to update it. So how big is this array? This array is the size of the whole thing, size of test positions. Okay, all right, and because this is an array, it's the total number of bytes for this whole thing, and it doesn't count these as pointers. They're actually taking space inside, right? And we divide that by the size of each item. So each item is going to be a position. So this is how many items there are. So now we can just iterate through a for loop. Equals 0, I less than len, and I plus plus. Okay. Next, we actually do the test, which is if, okay, we expect all these to, actually, I want to start off with a, oh, actually, right. we should set this up because I was thinking I should start off with a failing test, but I realized that I could just write the test, and then when I'm actually writing the win function, then I could set it up to see if I start with a failing test. So, okay, so the test here is if not win, win position, right, of the position. Actually, I'm going to just call it win, and I pass in the position. If it's not win, then we're going to complain. We're going to say printf, put some arrows here and say should win, and okay, might as well put the string right there. So this is the actual. Okay, should win. Maybe actually didn't win. Didn't win. Okay, isn't win. Okay, this is good. And I should print it out. So it is. Oh, actually, I didn't specify what pos is. So it's a position is equal to the test positions, and I'm getting the ith one. All right. So now I define what position it is. So that's the one that I'm working on. So it is the board. Okay, and return fail. And at the end here, if everything goes through, then I'm going to return success. Okay. So let's see if this works. Oh, actually, it's not going to work because we haven't written the function win yet. So here, I already have move. So this is going to return an integer, which is win, given a position. Okay, and I'm at, this is test, so test, let's see. I think I should reorder this right there like that. Okay, and I'm on the C part now. So I modified the header, now I'm going to modify the code. So the code will be returning an integer, saying whether or not it's true or not. So, so win, given a position. Okay. So by default, it will be return 0. So basically, no, it did not. It did not win. So everything should fail. So I run this, and oh, I put single quotes instead of double quotes for that one. Oh, for all of them. Okay, so then let's go back here. Let's go back to the test, and go all the way back here, and oh, yes, it's just these ones. Okay, switching them to be double quotes. Okay. And so I get my first error, and it didn't win, which is what we expected because we haven't written the logic for it. We have the code for win, but it's just empty right now. Oh, by the way, I have a Vim mode set up here in case you wanted to know how I turned a single quote into a double quote. I press CS double quote, single quote, and that'll change the double quote into a single quote. And if I want to change it back, it's CS single quote, double quote. So it'll change the single quote into a double quote. So that's kind of a quick way. And that's part of Tim Pope's, I forget which packet it is. And you can do this with brackets or any other delimiters. So like brackets or parentheses or whatever. So it's kind of handy. All right, so let's actually write the code for that. So the win. So the first thing we want to do is define what a winning row looks like. So let's see. This time, yeah, just win row is going to be depends on whose turn it is, right? So pos.turn, if it happens to be x, so if it's x's turn, that means that O just went. So that means that the winning row should be O's because O just made a move. So, and then it's X's turn. So it's all O's. Otherwise, it's going to be all X's. And there's 3 of them. Okay. And then we need to go through the buffer of the board. So for I int I equals 0, I less than 3, so just get 3 of them. Let's see. Well, we're going to actually, instead of using I'm going to use X and Y so that it makes it a little bit clearer. So we're going to go across actually the Y part. So we're going to go down each row. So Y plus plus here. And then we're going to go across the, actually, we can actually just do a string compare, string copy. So buff. So I'll just create a little buffer. So character buff, which is the size 4. Okay, and we're just going to collect it. And we're always going to have, we're going to collect the first 3 characters, but the fourth character is array 3, because since it starts with 0, the fourth character is 3. So that's going to be a null. It's going to be terminated with a null. So that's always going to be there. And now we're going to have to fill that buffer up. So for int x, start with 0. Well, actually, I said I was going to do string copy. Yeah, I guess I could do string copy, but I think I'll do it this way. So x is less than 3, x plus plus, and we'll just copy buff. X is equal to, and buff, oh, not buff, actually, yeah, that's right, the board. So that is the position of that board, and now we want to get the ith item. So this is the row. So because this is a row, we have to multiply by 3, and then plus x, right? Because if you want to go to the second row, you have to add 3, just like a calendar. And if you want to go to next week, you have to add 7 on the calendar. So this should take care of the buffer. And now we can just compare to see if this, now we can actually do the test for this. If the, string compare of the buffer and the win row is equal, okay, so if it matches all x's or all o's, whatever we're looking for, oh, actually, if it's not equal to, because this is the failure part, then we can just return fail. Oh, actually, not fail, because this is not a test. Oh, actually, okay, it returns 0. It fails. Okay. So I think that, let's see. Oh, actually, no, we just want to check to see if it wins. So as soon as we find the first win, we're done. So we do want to compare it to 0, and we want to return 1, right? So if basically this is saying we found it, okay, and it's going across. So let's see if that works. All right. So you can see here that the first one passed. So anytime that there's 3 in a row on a row, then it passes now. Now this is for a column. So we have to do a little bit of math to figure out how to do that. So since we can kind of reproduce this, except that now just to make the logic a little bit clearer, we can just sort of say for, we just kind of reverse it. Yeah. There's a different way that we could have done it too, using the same x and y and switching x and y here, but I might as well just do it this way so it's a little bit clearer. So we're going across all the x's. Oh, actually, it doesn't really matter, right? Oh, actually, then this doesn't matter. Okay, yeah, then I can do it here. So this one loops through and I'm basically going to copy this, but the arguments are going to be a little bit different because let's see, I am going across this way. So so because I switched this, now it's sort of flipped. So as x goes across, then this goes down the columns. So maybe using I and j would probably have been better instead of using x and y, because now I kind of, because if I did it the other way, then I would have to block copy the outer for loop and change some of the variables around, but it's just a variable change, variable name change. Anyway, so I'll just keep it like this. So this is the, so just flipped it around. So this way it's now, instead of doing comparing rows, it's comparing columns. And the buffer, the comparison should still be the same because it's stored into the buffer, 1, 2, 3 characters. And so let's see if that works now. All right, so that passed. Now this one happens to be the major diagonal. So it starts from, so the diagonal is going this way. So from the upper left corner to the bottom right corner. All right, and for that, I'm going to go outside of this for int I equals 0, I less than 9, and I plus equals 4. Okay, so this is kind of interesting because if it's 4, then when it goes to the next row, it's going to be the next row plus 1, so it's basically moving on a diagonal. And we copy that to I. Actually, we need to have another variable here, j, because j just gets incremented by 1, not by 4. So we need to have a j here that gets incremented by 1. So it's always in the next position, and the position will be board I. Okay, so this will, and we also need to have the comparison at the end. Just take this, put it here, put an if condition, and if that happens to be done, then great. So let's see. All right. Okay, and let's see. All right. So now we have the other diagonal to worry about. So we'll just copy this, and the starting point is going to be 2 because it starts from, instead of starting from the upper left corner, it's going to be starting from the upper right corner. And there's a little bit of a trap here. The trap is this. So here you have the 3 positions. So dot dot x. Let's see, yeah, dot dot x, and then you have dot x dot, and you have x dot dot. So the trick here, the problem here is that if we start on 2 and is less than or equal to 9, and we increment by 2, so it's basically to get to the next row is 3, but then you subtract 1. The problem is that if it goes by 2, then it'll also add an extra x over here, because if we're adding by 2, it's less than 9. This position is 8, so this is allowed. So this is what's going to happen. So to prevent that from happening, we're going to go an 8 here. So we just stop there. So we're just going to put in the characters for this x, and this x. All right. So that's a little bit tricky. All right. So this should work. All right. So let's see if everything passes, and everything passes. So now we have the 3 preliminary things to get set up. The third thing now, we need to set up another test. Let's see over here. Okay, we're going to have a test to check the value. Okay, so given a position, it's going to give some numeric value to it. And let's see. It's going to return an int, test value, and return success. And let's see. So how do we set this up? There's a few, let's see, I think it's going to be very similar to the way this is set up, where we have a position and we have some expected values. So I want to have them right next to each other. So actually, I'm just going to, this time, instead of array of positions, I'm going to have, let's see, struct. Well, actually, I can just probably say struct this. Just anonymous struct, because I don't think I'm going to be using the type. It's just going to be a position and expected value. So the expected value, and that's going to be an integer. Okay, and this is test items, let's say. Oh, actually, is equal to it. Okay, struct test items equals. Okay, so when I saying struct, I could specify the name of the variable. This is the name of the variable, and I could initialize it. And because I want it as an array, so put brackets here to say that it's an array. And now we're using the curly brackets, we can start filling them in. So the first thing is the position is, start with the curly braces here to fill in the position, and it will be x, 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 1, 2, 3, 1, 2, 3, and it'll be, it doesn't really matter what turn it is, I guess, O, right? So that's the position. But this is actually, this is an array, but the first item was a position, so I have to add that because the first one was a position. The second one is going to be expected value. So I'll say that the value is going to be 10. And if it happens to be the opposite, which is the O's, I want to have a negative value, negative 10. Another criteria that I want to test for is if it's a draw. So if it was XOX and XOX and OXO, so nobody wins, and it doesn't matter whose turn it is. And for that, we'll just say 0 because it's a draw. And it's like there's no more moves and nobody's won. So these are like the terminating conditions, right? That we want later on when we use recursion to figure out what the best move is. So we have this that will give the best, we'll give the value for these, and then we also want to have this situation where if you have two x's and a blank, right? 1, 2, 3, 1, 2, 3, and it's x's turn, then we know that this is going to be a 9. So it's going to be one less than the maximum value because the next turn he should be able to put an x right there, and then that will be a 10. So I don't want this to be a 10 quite yet. I want it to be one less because this way it'll find the shortest win. Because if there are two choices where one is a 9 and the other one is a 3, then the 3 means like you have some ways to go to 10, but 9 you're just one move away, so it'll choose the one that's 9. So that's why we have this system set up. So basically the maximum value you can get is 10, but any step removed from it will be one less, or one more in this case with a negative value. So we have this, and we also want the opposite situation. So if they're all O's and it's O's turn, then it's negative 9. Okay, so we have test value set up here. Let's set this up. So x turn int value given the position. Okay, and we actually write the code for that. So the code is, it's an integer value and it takes in a position. And for now, let's just return 0, right? It's like, it's always going to be a draw. So let's see what happens. Oh, it passed. That is unexpected. Well, this is not supposed to happen because we didn't set up the test right. The reason why is because we always said it was a success. We didn't put any tests in here. We just We just set up the structure, but we didn't actually use it. So now we actually put the test in here. So we loop through each item. So again, we do the same thing to find the length, which is the size of test items divided by the size of each one. So that is, oh, actually, in this case, I don't have a type to put in here. So I'll just say test items of the first one. Okay, so there has to be at least one. All right, so this is the length. So we just iterate for I equals 0, I less than length, I plus plus. All right. Then we get the test item. So, oh, that's a good question. Oh, no, we can do it. Okay, because we can have test item. So position is equal to test item I of position, and the expected, so int expected value, right, is the test items I of the expected. Okay, we didn't have to declare these variables, but if we're going to refer to it, then we have to refer this way all throughout the code, and it can get kind of big. Anyway, it's only 2 extra lines. So we have to put some tests here, a failing test. So if the, actually the value, right? So we need to call the function. So we would say value of the position, okay, and value, int value. We get the value of the position and we test it. If value, oh, it's saying that it doesn't exist, and oh, okay, I think we should go away soon because I declared it. Let me see what the error message here. Oh, the reason why is because my the function is called value, but I have a variable called value. So maybe value is a poor choice. Maybe I should have called it get value, but yeah, I'll just call it value. So, okay, so if the value does not equal to the expected, then we can put a nice little error message. Okay, nice little error message. Well, first it would have to return fail, and we will print out the actual is val %d, expected is %d, and so the actual happens to be val and the expected is expected. Okay. All right. I think that's all we need to do. And let's see if, yeah, we always put a 0 there. So now we should have a failing test. Okay, so we have a failing test. We're testing test value, and it failed because it expected 10. I should really put the board position so we know where we are. So I think in the test here, when we're printing this out, it's good to put the board. So %s as a string, and we pos.board. So we just print that out. Because when I'm looking at this, all I know is that it's 0 and 10, but it doesn't give any context of what's going on. So now if I run this, it is this, and that should have been a 10 because the value for this, he's 1, so we'll give it the maximum score of 10. So let's go in here and make it real this time. So, which is pretty simple because because we have the function win, we can say if the position is a win, actually we always have to put parentheses, if it's a win, then we're just going to return 10, but we have to be careful here. So if the turn, oh actually it's a ternary operator, so you don't need the word if the position dot turn happens to be x, that means that O just went. So if O just went and it's a win, that means O just won, meaning that, oh, that's a question mark. That means O wins, and that means that's a negative 10. Otherwise, it's a positive 10. So let's see if that passes the test. That passes the test. And we also have the negative of that too. So when it's O, then that also passed because that was part of the test suite that we made for test value, and that kind of skipped it. So now we're on to the next part. Actually, there is one other part that is a little, okay, so I'm going to put a nonsense value in here like 999, right? So when I do that, then this shows up because the draw. This, when something like this is detected, then it should be a draw. So how do I know when that situation happens? Well, there are no spaces. So how do we know? What's a quick way to test if there's no spaces? Well, there's a string CHR, okay, and the signature for that is it takes in a character string and an int. Now this int thing is kind of interesting when you're passing in characters, I'll show you what I mean. So if I do pause.turn, not turn, board, if I'm going through the board and I'm looking for a blank space, when I put a single quote, this, you would think that this is a character, but actually these little literal characters are integers. And that's why it gets a little bit confusing, because when you saw the signature for string CHR, it was expecting an int for the second argument, and it's a character, but this really is a character. One thing to note is that when you're going from C to C++, literal characters like this is actually a character instead of an integer. So that's one thing that you should be aware of. And the other thing to note is that when it says character, like when you're defining strings like a character star or a character buff like this, then each element of the array is a character size, which means it's 1 byte. Yeah. Well, anyway, so this will look for it and returns you a pointer to where it's located. So if I mouse over here, you can see the return type is character star. It's the very first thing. It says character star right there. So if it didn't find it, then it's going to return a null. So I can compare this equal to null. So that means that it did not find it. So if this happens, then return 0, because that means that it's a draw. Some things that you might see, instead of seeing null like this, is they would say 0, because if you take a look at null, okay, let me see if I mouse over it, it shows you what's defined as. Yeah, well, just, I'm going to control right bracket this. And, all right, so null is defined as Darwin null. Let's see what Darwin null. See, the null is actually defined as a 0, but it's typecast to be a pointer to a void star. So basically it's a 0. And some people like to use 0 instead of using null, because 0 can be of any type. So not just the void star, because sometimes it'll, I think void can work with anything, but some people like to use zeros. And because it's a 0, 0 can also be a Boolean. So doing something like this, sometimes you'll see it like this, and sometimes since 0 is treated like a not, as a false, right? That this is false, then you can just say not this. And sometimes you'll see it like this. So there's a lot of ways to write it. So for me, I'll just do it this way. So if it's not found, then actually return. You don't want to return 1. You want to return a 0, because that's a draw. Wait a minute. I am in the wrong place. This is not what I meant. Okay, I was over here. Okay, so this is what I meant. Yeah. So this. Okay, so this should work. Let me run it now. So now it passes for that part, and we're getting to this other part. Now this other part gets a little bit tricky, because now we have to use recursion, because we have to test out like we have to put the next move to all the possible moves and then see what the maximum value is. So we'll have to, okay, so there are two cases. Well, first let's write the code for the maximum and then we'll do the case for the minimum. So if the position.turn happens to be x, that means that we're trying to maximize the score because for x we want to look for a 10. Okay, so if it's 10 and then we have the else clause, right? So for int, okay, so we're going to go through the whole thing. I is less than 9, I plus plus. If the character, so the board, pos.board, if the character does not equal to a space, then we just continue. We'll just say continue. I'll just put it right there. So just a little guard clause saying like we only care about empty spaces. So now it's like at this part of the code, we know that this is a possible move that they can do. So we're going to actually do it. So now we'll say next move, next position, actually. The next position is going to be the position, actually it's move position, comma, I. So we make the move and we want to get the value. Oh, actually, we don't even have to have next position. We can actually do it right away. We can say value of that. Get rid of that. So now we have the val. Okay. But when you're going this, okay, actually we have to declare the type. So when you're going this way, we're trying to maximize it. So we have to keep track of the current value. So int current is equal to, and it's like, oh, actually we'll just keep it blank. But if we're going to be doing it that way, then we need to have another type called init. Yes, we have to. Yeah. So basically, so if it's init, means like if this is the first time through the loop, remember that cur is not set. So if it's the first time through the loop, then you want to just set the current. So the current is going to be the value. And then we have to say init is equal to 1. So this way, well actually I would say it's not init. If it's not initialized, then we're going to set the current value and we're going to set the init to 1. So now it has been initialized. So now in the else clause here, this is where the logic happens. So we'd say if, actually it is, since we're trying to maximize it, if the value happens to be greater, actually I like to do it this way. If the value is greater than the current is less than the value. I like using the less than. This way I could visually see which one's greater, because if I always use less than, then the greater value is going to be the one on the right, just like the number line. So if this is the case, then we want to actually set the current value to be the value. Okay, and I think that's about it. And then once you're done, at the very end of it, you have the maximum value and you want to return the current value, right? But this is not, I mean, now I have to like make a whole copy of this code just for the what happens if it's O's turn. But if you actually look through this code, the only place where it makes a difference is this part right here. So I can just take this out because this code is going to be duplicated for O as well. So this is the only place where I need to deal with it. So if, okay, I would say if the position dot turn happens to be X, then we're trying to maximize it. So now we have this other condition, which if the turn is X, then we're trying to maximize it. So we do that. Otherwise, if now we have to actually, we can't just have an else clause because there's additional logic here. So with an and. So, and now we're trying to minimize it, so it's the opposite. So if the value is less than the current value, minimizing it, then now we want to store the current value. And then once we go through, then we should have the current value of what we want, and there you go. Oh, actually, then we can get rid of this. All right, so that should take care of almost. This is almost. We're almost done. Now if we run it, it will be close. Okay. So the actual value is 10, but the expected is 9. So one thing we have to do at the very end is, if it is a positive value, then we want to subtract 1. And if it's a negative value, we want to add 1 to get it closer to 0. So at the end here, we need to have an additional if clause. So if the current value, with the current parentheses there, if the current value is greater than 0, then return current value and then we subtract 1. Else, if the current value is less than 0, then return cur plus 1, so we get closer to the 0. And then we just return cur otherwise. So which means that it's 0, so that takes care of that. So now if we run it, everything passes. So we have one last part to do to make this a perfect game of tic-tac-toe, which is to find the best move. Since we have most of the stuff already done, the best move is actually should be pretty straightforward. So test best move, and for the best move, it's test best move, not best move. Test best move. Test best move, and let me see. For the best move, I'm going to set up a very similar structure like this. So I'm going to copy that, put it right there, and we have some expected value. So let's see. In this case, there's no moves because this is a 1 position. This is drawn position. So starting from this, I want this to be a 9, and actually the expected is going to be the expected move, so not the value. So 2 should be the answer, because if it's x's turn, then 2 is where you want to be. And 2 is also the position for this as well to win. But also, if it's O's turn, then 2 is also a good move, because that blocks the win. Okay, and might as well do this one here too. So if it's x, okay, just to make sure that just a little sanity check, I'm going to also do one that's going down the column. So if I put an x over here, so 1, 2, okay, actually x over there, and so the winning move for if it's x's turn, the winning move should be I think this is 6. So 0 and add 3 would be 3, and then 6. So 6 would be the winning move in this case, and for if it's O's turn, then 6 is also the move. Just change this and change this to an O, and same thing for this. Same situation here, blocking or to win. So they all want 6. So I have like 2 special cases that I have. This should be good enough, and we can put into a for loop. And we have test items here, so take this, put it right there, and loop through. I might as well, like, the good thing about having structures like this is I might as well get the success as well. The good thing about doing stuff like this is that once you have a good structure, you can apply it to other places in the code. All right, so okay, so let's look through this. We have the length, we're iterating through, we get the position, we get the expected value. So instead of calling value now, we are going to call best move on the position, and we really shouldn't call it val because it's not really a value. So I might as well call it, I don't want to call it move because we have a function called move. Actually, these names are pretty bad because they could also be names of variable names, and so we should either have namespaced it or say move underscore position, something like that. But for now, we'll just do this, and I'll leave it as an exercise for you guys to refactor. All right, so I'll just call it best move M. All right, so if the M is not expected, then we have the same output. Instead of value, we have the M, right? Okay. All right, so let's just, oh, actually, the code doesn't exist, so it's not going to run. So extern int best move, given the position. Okay, and then here, we're reaching now almost 100 lines of code. So int best move given the position. Okay, we didn't specify pause. Okay, so given the position, we want to find the best move. Okay, so for now, we'll just always return 0. It should fail now. At least the test will run. So if I run this, it'll fail. I got a 0, but expected a 2. So that means that our test is working, and now we just have to make the code work. All right, best move. Okay, so let's think about this. So to make the best move, we have to do the same thing that we did before, which is we want to iterate through, see, value. Yeah, we want to iterate through everything and all the possible moves. So this part will give you all the possible moves, and okay, and it'll just continue on if it's not an empty slot. Then we want to try it out. So get the value. So val is equal to value of the position. Oh, actually, not the position. It is the position after you make the move. So we have to make the move on the position on I, and then get the value, right? So that is, let's see, int, right? So now we have the value for that particular position, and we want to keep track of the current value because we're trying to maximize or minimize. We're doing very similar thing with the value, but it's a little bit different. All right, so we're trying to maximize it or minimize it. So int cur and int init is set to 0. It has not been initialized. Normally in Python you would set this equal to none, but because in C, it's strongly typed, so it could only be an integer. There's no none, so we have to have an extra variable here. So here we have the value, and we want to compare it with the current one, but we can't if it hasn't been initialized. So if not initialized, then okay, set the initialized, but then we would we set the current to be the value. But not only that, but we want to keep track of the I. So the current I is also going to be I. So we keep track of which move it is. So cur I. Okay. All right. So it's a little bit different because we have an extra variable that we want to keep track of. Now the else clause is where it's else. Okay. So if the turn happens to be x, right? Position.turn is x. What we're trying to do is we're trying to maximize it. So we say if it is x's turn and the value happens to be greater than the current, then yes, we do want to update. So then the current value is going to be the value. The current I is going to be the I. So we keep track of the I. But we're using value as the condition that we're testing for, but we're keeping track of the I, the associated I. And then we need the else clause here. So else if this is for the O's case, That means that the value has to be less than the current. That means, okay. Then we want to store that. Okay, so that means that we are keeping track of the current I, and instead of returning 0 here, now we just return the current I. So so current I is the best move, because we went through all the possible 1 through 9. We went through each one. If it's not a blank, that means that it's not a possible move, so we just skip it. And then we make the move, get the value for it, and check to see if that's the maximum, and always keep track of the maximum, and that's the I. So that should work. So now let's see if that works. Okay, great. So we have everything that we need to make the tic-tac-toe game. There are some other things that would help us when we're writing the game. For one thing, we need to know when it's a draw, because that is the terminating condition, because we have the win, but we also need the draw to make sure that we know when it's time to end. So let's put a little test in here for test draw. Okay, now it's the simple stuff. Draw. All right, so int test draw, and that will be a, let's see, if it's going to test the draw, then given a position, so I'll just give one position. So if the, actually let's just, position is, the position is XOX, XOX, and OXO. Okay, and I think it's like O's turn after that. Okay, so we have a position, and we want to test to see if that's a draw. If not draw of the position, okay, because it should have been a draw, then that's an error. Return fail, and print a little error message here saying that, okay, we should actually print out the board. So let's print out the board, and is not draw. Okay, and I always have to put a new line there because it doesn't do that automatically. Then we need to, okay, so for this, the argument is the board. I think that's it. All right, so that's our test. And let's save this. Oh, we have to draw, given the position. And for this one, we're going to make a dummy function here. So int draw, given the position, and it'll always return position, and it'll always return true, false. Let's say false. All right. So we have a failing test. It's not a draw. All right. So now it's like, how do we know if it's a draw? So the test is using that string chr, stir chr. So looking at the board, can you find a blank? All right. If that happens to give you no result, right? It's a null. That means that this is a draw. It's a draw if there's no more blanks. Okay, so let's see if that works. And everything passes, great. So we have everything, so we could make the UI part here, and for that, I'm not going to do a TDD, I'm just going to just write the game part. So one thing to note is that while I was doing all of this stuff, there's only one main. So that the main is the beginning of the code for C programs. We have a main here, so we're going to create a new file with a main. So we'll call it game.c. And so when we run, instead of cc, oh wait, there's a warning here. Test 116. Oh, let's take a look. Before we do that, let's take a look at 116. Something about 116 over here. there's no, I don't have a default return value here. So that's a return success. Okay, yeah, forgot that. Got to make sure that we don't have any of these warnings because unpredictable things may happen. Okay, so it's all passing. I had forgotten that. So now for the user interface, we have everything that we need. So we can hash include the TTT header file, and we can int main, and I think return 0 or something. I forget. I think the way the main works is that if you return 0, that means it's a success, because otherwise it's an error code. That's why it's a 0, because any non-zero, you would have an error code, and using the error code, you could figure out, error messages and stuff. All right, so we have the main, and let's get a position. Oh, there is one other thing that I want to do, but I didn't want to put it as a test because it's kind of tedious and doesn't really add much to the logic. It's visual anyway, which is to print it out. So once we have a position, which is, what did I call it, create position of, yeah, just create position, and just print position. That's all I want to do, just print it out. So if now instead of running test, I am going to use game. And okay, print position doesn't exist, so that's why it's complaining. So for this one, I'm going to create it. So there is extern, it's a void, print position. Okay, given a position, it'll just print it out. So let's just have that here. So void print position. Okay, so let's see, we can iterate 1 through 9 or 1 through, okay, actually let's start with the rows. So for let's see, rows would be y is equal to 0, so y is less than 3, y plus plus. So we're going down the rows, and then we're going to go for int x is equal to 0, x is less than 3, x plus plus, and then we just have an index, so that is just y times 3 plus x, and we just doing something really simple. We're just going to print percent c, the character, and the character is going to be the position board I, and after each one I'm going to I'm missing a semicolon. Okay, and then after each time we do go through a row, I'm going to print a new line. Okay, and yeah, we'll just see how this, I mean, this, when I run this, oh, okay, so the complaint is that for this game, I'm, oh, actually it's not in here, it's part of this. Let's see, this is saying, this is coming from ttt.c, because in ttt.c, in this file, I'm saying printf, but I need to go to the top here and include standard io.h. Okay. By the way, the difference between angle brackets and double quotes is that angle brackets looks for stuff in the system library area, usually like user include something, and double quote means it's in my work area, the workspace. Anyway, so let's see if now it works. When it's first initialized, of course everything's going to be blank, so it's not very interesting. But one thing that I wanted to do here, oh, actually, before I do this, in the game, just to like have something in there, I'm just going to make a move. So position happens to be making a move of 1. So now there should be something that should appear. All right. So now if I run, now x appears. Okay, so now we have to put in the grid. So for the grid, let's go back here, and we're almost there. One other thing that I want to do here is, let me just take this out and just put this as a C. Okay. Okay, so this is the character, and if C, if that happens to be a blank, then instead of like putting that in, I'm going to put in the I. Actually, because this is a character that is putting, I just can't do that because then it's an ASCII value of the index. Well, so I want to turn this into a character, and the way that I can do that is by adding it to a 0 here, plus. So again, this when you do stuff like this is actually a number, which is I think like 48 or ASCII code, and then whatever offset it is, then it'll just luckily those numbers are in sequential order, so this will work. Otherwise, it's just C. So now when I print it out, you'll see numbers and where there's blanks, and then I just need to space it out a little bit. So okay, so one thing I want to do here is I wanted to put a little spacer. So let's see, character star X space separator is going to be empty in the beginning, and then after the first one, then I want the separator except to be that. All right. And initially, when it starts off, I wanted to put an extra space. Start off with a space and then use this as the separator. Right. And we have to include the separator by putting it right there. And that is the next argument, so xsep. All right, save it, run it. Okay, and we want to put like little dashes in between, so it actually looks like a grid. So that means that so the first separator, it will be character y separator is empty. So when it goes in, so the very first thing that it does, actually I should do it after this, print, let's see, I think dashes, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we have the 2 bars. Okay, so that's that many, and a new line. Oh, actually, that is not what I meant. I want to printf %s, and that will be the ysep. Okay, and this one, this what I meant for this was after we print it out, then we can set it. But I could also set it over here. Oops, at the very end. So ysep is now this. So the next time around, this will be the y separator, and so now it starts. So let's just see. Close, but we have too many carriage returns here. I don't see why. It's because we do have a carriage return right here, so we don't need that anymore. We don't need that anymore. Why don't we need that anymore? It's interesting. Where's the extra carriage return? Oh, I see. We don't need, I put a carriage return right here, so we don't need to put the carriage return as part of the separator. So, all right. So that's exactly how we want it to look. And now we can go back to the game here, and we have a representation of it. So the first thing is we create the position. We don't need to move now. Now we just print the position, then we can say move, we're expecting a number. Just do that, and we use scanf, and then we want to read in whatever they type in. We're going to read it in as a number. So I'll just say M. right? Actually, I've been using I, so I might as well use I. Okay, so now it is ampersand I because we give the address of I, because otherwise, since C is copied by, passed by value, that means that the value is going to be like copied over when it's called, then there's no changes that will be stored. So you have to pass, it's expecting you to pass the address of the variable. We haven't declared it yet, so we'll declare it here int I. And it'll read it in and store that into our variable I. And then we can make a move. So we can say move, the new position is going to be move the position I. Okay, and then we can just print it out again. So print position. Okay, scanf. Did I scanf? Hash include standard io.h. Okay, so now it's asking me for my move. I'm going to say 0 in the upper left corner, and it made my move. So this I'm going to actually put into a loop now. So I'm ready to, so let's see. First, should I just put into an infinite loop? Yeah, I guess I'll just put into infinite loop, and then just have a little break to. Okay, so we have the position, we have the move. All right, we don't need this extra print position because that's going to happen once you make the move. Now, once it prints the position, there's two cases, right? So if since you're, for now, just to make it simple, you're always going to be X. So if the position dot turn happens to be X, then we're going to ask for your move. Okay, and actually this over here. Okay, we're going to ask for the move, and once we get the I, we're going to make that move, and then we're going to loop through. The else clause is the computer part. So instead of so what we're going to do for this is if the I is going to be best move of the position, and we're going to make that move. So position is equal to move based on that I. Okay, we could have combined it. We could have just put like best move inside here, but we'll keep it separate. And once it's moved, oh, actually we don't need to move it because that's what this thing is here for. Okay, so all we need to do is set the I. Okay, now there's what we want to do is like if we'll put a little test in here. If win, okay, if you've won, then okay, so then you say you win. Okay. And actually I'll put a new line there, and then we can just break out of that loop. So we're done. In this case, if it's a win for the position, then we can just say computer wins. Okay, and then we can break. All right. One other thing that we need to be careful about here is the draw, because once okay, so nobody has made a move yet here. So in this situation, I guess like while not draw of the position, I think this should take care of it, and it'll just pop out. And so now it's going to pop out, and you don't know whether or not it's because of a draw or not. So we put a little test here. If it's a draw of that position, then we want to print out that it's a draw. So draw. And we're good. I think that's it. Otherwise, if it ended, then it would have had one of these two messages, either you win or the computer wins. So we're ready to run this. Okay, so I'm going to type 0 here, and let's see, the computer made a move over here. So I'm going to try to trick it and go to 1. And you can see that the computer has blocked me over there. And I go to 6, but let's just say I go to 5 instead. So if I go to 5, then the computer should choose 6. I went to 5, and the computer went to 6. It won, but it didn't terminate. So it's a good question, like what happened there. So the reason why is because although it chose the best move, it didn't actually do the move. So so actually, might as well move this up here then, because we want to make it as part of the logic, right? Otherwise, like if we brought it outside, then we don't know what case we're in, then we have to do that if thing again. So if I brought it in here, so you do actually make the move inside here, I'm duplicating a little bit of code, but otherwise the logic would have to be moved outside and it gets a little bit messy. So let's try this again. So I go to 0, it goes to 4, I go to 1, and it goes to 2. I'm going to block, I'm going to go to 5, and it should pick 6 to win. And it goes to 6 to win, and it says computer wins. So let's see if we can play perfectly. So if I if I go to like 4, let's say, I went to 4, he went to 0, and I went to 7. Now let's go to 2. That's going to be tricky. So I go to 2, and he blocks. Well, he blocks me on the 6, and I'm going to go to 8. Oh, I screwed up. The computer wins because it went to 3, then printed out. So that's interesting. So I think like I need another print statement here. So like once it makes a move, then it breaks out, and I might as well, okay, if it's a draw, then we just say, otherwise we do the final position. I didn't print out the final position, so the final position, because it broke out, it didn't actually, because the print is on the beginning of this for loop, so it never got to do the print. So I might as well do the print over here. So either it's going to print that it's a draw. Actually, like it should always print it out, not only, because even if it's a draw, we should see the final position. All right, so let's try this again. So I forget what order I did. I did 4. I went to 1. It blocked me. I'll go to 8. And I go to 5. He went to 3. And I go to 6. And that's a draw. And you can see like it did the final position. So so that's it. This is Tic Tac Toe and using C. And some of the interesting things about this is it's quite unusual to see like test-driven development using C, because they're really, like, I haven't found any packages that really do it, or at least, if there is, like, it must be pretty confusing, because I tried Googling for it. But anyway, it wasn't really hard to write your own test suite. So I should really put this up on GitHub so you guys can take a look. So I hope you enjoyed this.